So here's how I did it. All right, so I decided to call the array that has the measurements meas, input, enter the measurements in, and just a reminder for the user to put them in brackets. Units equals input, enter the units, and this is going to be text, not a number, so I put comma and then an S in quotes. And then I print out the average of the number of measurements is an integer, so that's %i. Measurements is, it said to print out the average with 2 decimal places, so that's %.2f. And then the units is a string, so that's %s. And then to get the number of measurements, you can use length. To get the average, you can use mean. So just use the same numbers I had before, just to save me the typing. And let's say they're in kilograms. All right, so the average of the 4 measurements is 87.75 kilograms. All right, any question about that? And again, you could do this with DISP as well, but I think it's just cumbersome because you have to mix in all these pieces of text with the 3 different values. In this case, I really think it's more convenient to use fprintf. All right, quick review of plotting. Now, MATLAB has all kinds of capabilities for plotting that we don't cover in this class. False color plots, pie charts, contour plots. In this class, pretty much all we do is simple line and scatter plots. Although at one point, we may have you do a histogram as well. All right, so basic line plotting. So let's say we had some numbers, y. I'm just going to generate some random numbers here and just do plot y. All right, so it generates a plot. And if you don't give it x values like I did here, so I didn't provide anything for the horizontal axis, it just puts the index, in other words, a number from 1 to 1,000 in this case, because there are 1,000 numbers, on the horizontal axis. And it just looks random because that's what it is, just random numbers. Now, more often, of course, you're going to have y versus x. Okay, so you have some y data and some x data. You plot y versus x. And so if we're plotting a mathematical function, often what we do is generate a grid of x values like so, yeah, either with linspace or with this colon operator. Calculate the function. Now here I'm using the figure command to open a new figure window. Otherwise, it would overwrite the previous one. Now, you actually don't see that with a live script, but with a regular script, that's what would happen. Okay, if you just do a second plot command without opening a new figure window, it just erases the previous plot. So if you want to keep both plots, open a new figure window. All right, so I'm plotting. Now notice that people get tripped up on the terminology here. When we say plot y versus x, that means plot x comma y, okay? Because y versus x means y is on the vertical axis, x is on the horizontal axis. But when you put them in the plot command, it's in the other order. It's x comma y. And if you want, you can then put a control string to control the color and type of line or marker. So here all I'm saying is plot it with a black line. Okay, K is black because B is blue. All right, so this would make it a black solid line, whereas the default would be a blue line, like you see here. All right, then of course, any plot is not complete until it's annotated with labels on the X and Y axes, a title, and you only have a legend if you have more than one data series, right? So I'm not putting a legend here because there's only one data series. All right, so I get a plot of a simple quadratic. And another common bad practice that we see, sometimes the title will be redundant with what's already said on the axis labels. So let's say the axis labels were like acceleration and time. We'll often see people put as a title, acceleration versus time. That's a bad practice. It doesn't add any information. Okay, this should be more descriptive. Well, the acceleration of what? Right? Like the acceleration of a skydiver versus time, something like that. And so remember, the title should be more descriptive. It shouldn't just be the same thing that's on the axis labels. All right, and one more thing you might want to do is control the axis limits. Sometimes when you plot things, you end up with empty space kind of on the edges. If you want to get rid of that, you can set the X limits. This says go from -5 to 5, which you see is what it's doing. And the Y limits from 0 to 25. Okay. So if you plot something and the default limits that it shows for the axes don't look good to you, you can control it yourself. All right, so that's basic plotting. Now, what about when you want to put multiple plots on the same graph? I'll show you a couple of ways of doing that. One is you do the one plot, and so I already did the first one here. And now I want to add something to that same plot, add a second data series to the same plot. I can type hold on, do the second plot, and then hold off. So that tells it, instead of overwriting the previous plot, overlay this second data series on top of it. All right, so now I'll have both data series on the same graph. And the usual practice here, solid line for the theoretical curve, and an asterisk for the experimental values or measured values. All right, so this says use a black asterisk marker instead of a line. All right, second way of doing the same thing. Okay, so I'm going to make a new figure here, start a new plot. And I can actually put both data series in the same plot command. Okay, so plot Y versus X using a solid, and this says a dashed line. So 2 dashes means a dashed line, a black dashed line. And then plot Y prime versus X prime using a black circle marker. Okay, an O is a circle marker. Okay, X label, Y label, title. And now, since I have 2 data series, I should have a legend. All right. And when you do the legend, all you do is you put legend, and then you put the text items that you want in the same order that you plotted them. Right? So when I did the plot, Y versus X came first. So theoretical is the legend item for Y versus X. Experimental is for Y prime versus X prime. All right, so now I've got a complete plot, fully annotated with 2 data series on it. Okay, and we recommend, just like in 11E1, that you do everything in black and white so that if you print it out on a black and white printer, it's still distinguishable. All right, a couple more things you might want to do with the plot. So I showed you one way of scaling the axes before. Okay, X limit, Y limit, if you want to do them separately. You can also do them both at the same time, the X and Y dimensions at the same time, with the axis command. That says the X limits are from 0 to 3, the Y limits are from 0 to 12. And another thing you can do is add a text annotation to a plot. So this says go to the coordinates 0.58 on the plot and put this message. Okay, and those coordinates will be the location of the lower left corner of the text. You can see 0.58. It's where the text begins. All right. one last trick that's sometimes useful. Sometimes you have multiple data series you want to put on a single figure, but you can't put them on the same axes because they have different dimensions. Like later on when we do simulations of mechanics, we might say plot the position, velocity, and acceleration versus time. Well, those are three different quantities with different dimensions. You can't put them on the same axes. So you can use a subplot, which puts multiple graphs in a single figure. All right, so again, I'm starting a new figure here. And subplot says this is going to be a layout of three plots. Let me just do that command first and show you what it does. Okay, you see it made you can kind of tell, even though it only started the first one, but you can tell there's room here for two more plots. Okay. And we did 3 by 1, which means that three plots are going to be one on top of the other. Okay, 3 rows, 1 column. And this just says, give me the first plot. But all this command itself does is make a placeholder. Right, there's no actual plot there yet. Then you supply the actual plot command, and it puts it in that first position. Okay. Then, whoops, keep doing that by mistake. Then you want to go to the next one. So you put subplot 3, 1, 2, and people get confused about these three numbers. Remember, the first two are just the dimensions of the subplot. It says it's a 3 by 1. The third number is which of the three plots you're doing right now. First plot, second plot, third plot. And everything else is just the standard plotting commands. Now you can do X label, Y label, title, legend with each of the subplots if you want to, but the usual practice is if the three plots, or the multiple plots, however many you have, if they all have the same x-axis, you normally only label the bottom one. Right? It would be redundant to put x values each time. And typically you only put a title on the first one, unless the three are all sufficiently different that you think is necessary to have a separate title for each one. Commonly, you would just put just put one title for the first one on the top one. All right, let's do one more little practice problem.